This is section 3, continuity, example 2. So for this example, we want to find where the values of x are not continuous, right? We want to find which values of x the function is not continuous at. So first, we need to know in general which types of functions are and are not continuous. So if you look at this table, and this is in your notes, it's kind of a summary of all of the ways and types of functions and where they're continuous and where they're not. So first, all polynomials are continuous for all values of x. Okay, we don't have to worry about polynomials. Remember that a fraction is only not continuous where the denominator equals 0. So that's important. If it cancels, it creates a hole. And if it does not cancel, it makes an asymptote. Either way, it's not continuous. A radical with an odd root is continuous everywhere, but if it's an even root, you have to see where it's less than 0. And trig functions are sine and cosine. Those are continuous everywhere. Remember, tangent is not continuous everywhere. It's full of asymptotes, right? And then exponentials are continuous everywhere. So that's just a nice summary of where things are and are not continuous. If you ever forget them, you can always look back at this. For example 2 in particular, we want to see where it is not continuous. So first let's look at and analyze what's going on here. We have the absolute value of x. Well, the absolute value of x, in case you don't remember, is a v, which is continuous everywhere. So we don't have to worry about that. We have 1 over x plus 1. Now that is only discontinuous at -1. Well, we're not worried about -1. We're worried about 1 to 3 for this particular function where that would be the case. So it is continuous over the domain that we're talking about. 2 is continuous everywhere, it's a number. And the square root of x would only be discontinuous where x is less than 0. And again, because we're talking about x greater than or equal to 4, not an issue. Okay, so we're only worried here about where it switches from one equation to another. So let's focus on, so we are worried about where x equals 1, 3, and 4. And I got those numbers because from 1 to 1 it switches here, from 3 to 3, and then from 4 to 4. So that's where those numbers came from. So in order to do this, I'm going to have to find the limit as x approaches each one of those numbers from the left and from the right. Because it's a piecewise function, we have to test both sides and make sure that they're the same. And if they're not, then it wouldn't be continuous there. Now remember, our answer is where it's not continuous, so I'm going to end up circling the ones that are not continuous. So let's see. We're going to find the limit as x approaches, let's do 1 first. 1 from the left of f of x. Okay, so from the left, that'd be the absolute value of 1, right? Which is just 1. So now we find it from the right. The limit as x approaches 1 from the right of f of x would be 1 over 1 plus 1. Well, 1 plus 1 is 2, so that's 1/2, which means that because 1 does not equal 1/2, it's not continuous there. Okay, let's keep going. Let's do the limit as x approaches, what's the next one? 3 from the left of f of x, which means we're plugging it into 1 over 3 plus 1, which is 1/4. And then the limit as x approaches 3 from the right of f of x, which is just 2, right? Because that's the function to the right of 3, right? Between 3 and 4. And it's just a number, so the number is just the answer every time. Well, those aren't the same, so it's discontinuous at 3. Okay, we're only worried about 4 now, so let's find the limit as x approaches 4 from the left. And when we do that, we get 2, right? Because that's the left of 4. And the limit as x approaches 4 from the right is the square root of 4, which is just 2. Well, hey, look, those are actually the same. So 4 is not one of my answers because remember, I'm trying to find out where it's not continuous. So it's not continuous. Final answer, not continuous. I'm going to abbreviate as CONT. at x equals 1 and x equals 3. And that's it.